Yeah, awesome. I think a great place to start would just be an intro on the origin story of the company, the core mission, and about your transition to extraterrestrial mining from renewables and aerospace.
Great question. Well, I think it would be best described as me coming back home to space. I literally started my career in the early 90s working as a designer on the International Space Station, aerospace engineering by training. Moved from Canada after working on a couple aircraft programs up there to California, Huntington Beach, to work at McDonnell Douglas Space Systems Company on the starboard one and port one segments, specifically on the thermal radiator rotary joint ORU, which is the system that keeps the astronauts warm and comfortable within the space station and cool also because we're rejecting heat into deep space. Migrated from there after grad school at USC into working in international business development for Hughes Space and Com globally, and from there spun out a startup company actually with a couple other Hughes executives that we called Protostar, one of the early space commercial space startups at the time. Space operator, we're focused on direct-to-home satellite television in Asia, working with major Indian and Indonesian customers. Sold a couple of those satellite assets in space. Got a call from my colleagues at Phantom Works in Huntington Beach around that time. And they were telling me that they had just purchased Hughes Space and Com. This was now Boeing that had bought McDonnell and Hughes, and saying, you know, the Phantom Works organization was trying to figure out a way to break into terrestrial solar. And so asked me, because I'd raised several $100 million worth of capital with Protostar, to look at becoming a terrestrial solar development company. And so I moved to set up an entity in Canada. We developed a several hundred acres solar farm at the time that we ended up selling to KKR back in 2011. So really got my head around structured financing for large scale terrestrial infrastructure, particularly, you know, space technology, solar space technology, which we're using to benefit the planet for zero emissions electricity generation. From there, I went off and I, started developing large scale smart grid projects. And then after successful, sort of launch of a smart grid project in Canada, made my way back to space. Reconnected with a lot of my former colleagues from Protostar, and we got going looking at mining the moon for water-based propellants in conjunction with a company that was doing that, and then looked very firmly at the most valuable thing that there is on the moon, which is helium-3, which is the place to start for any space resources story where you can close the business case. So that's where we are. Founded Extraterrestrial Mining Company about 2 years ago, building, that in Pasadena, now building the team in New York City.
Yeah, absolutely. And I think be helpful to give a background on helium-3. I think the last estimate I saw was it's about $20 million per kilogram from the Department of Energy. And so its abundance on the moon versus Earth. And then what are some of the use cases for it terrestrially?
It's a superb question. Yeah, because of its value, it comes from the decay of tritium primarily, which is what we use here in the US and Russians and China on thermonuclear weapons. So it's in the warheads, and it decays over 12 and a quarter years into helium-3, about half-life of that. Occasionally we have to take the warheads. The Department of Energy takes the warheads and removes the helium-3, which we then find it's an extraordinarily useful isotope of helium. Here, primarily, we've been using it for national security applications, which is a neutron detectors at the border. Department of Homeland Security consumes about eight-ish kilograms a year, which is 80% of the supply that we produce for neutron detectors scanning shipping containers at the border. There's larger applications also for medical as a hyperpolarized gas, which can be inhaled to mark for MRI scans of the chest for things like asthma and COPD and others. So those are the two major sort of current applications. Then it turns out that it's an extraordinarily useful refrigerant for quantum refrigeration. Qubits have to be chilled down below 10 millikelvin to maintain coherence so they don't disentangle with their pair. And so in order to do that, the only refrigerant available on planet Earth is helium-3, which we use in dilution refrigerators. And then it turns out at the other end of the spectrum, at 1 billion degrees Kelvin, it actually fuses with another helium-3 molecule and creates a burst of energy. So therefore, and it does not create neutronic radiation. So it's actually an extraordinarily powerful fuel for fusion reactors that are not radioactive. So right now, we're not using a ton of it, but there's a lot of quantum data centers in development and fusion reactors that are using helium-3. And once we start deploying these commercially, we're looking at a very massive uptick in demand. And we only produce about 20 kilograms on planet Earth. Just for quantum, it's looking like several hundred kilograms per year will be demanded just for the IBMs and the Googles and Microsofts to deploy quantum computing data centers. And then once fusion really takes off commercially, each fusion reactor of a gigawatt or so will be consuming about 50 kilograms, 50, which is 5 times, 2, 3 times the current supply available. Turns out it's on the moon in great supply, 1.1 million tons estimated by NASA.
Yeah, absolutely. I think as fusion becomes more ubiquitous, it necessitates going to the moon and bringing it back. Exactly. So, how do you envision the impact of lunar helium-3 mining and returning to Earth, kind of changing Earth's energy landscape? What does it enable for humanity?
Well, a big macro movement ongoing right now is the electrification of our economies, plural.
Mhm.
We've done, the majority of electrification to date has been within domestic and industrial applications. The globe produces around 7 terawatts of electricity generation. If we are to decarbonize and electrify transportation and industry, which is happening on a global scale, it's likely that we'll have to at least double the electricity generation profile to 14, 15 terawatts globally. And that, to be blunt, doesn't really take into effect a lot of the AI data center drive for electricity that's really, really pushing the envelope in terms of what's available for clean electricity generation. So given the fact that we're going to be doubling our electricity generation globally, and given that fusion in particular is looked at as one of the major approaches to baseload electricity generation. Fission will take its place with solar, wind, electric, other forms of electricity generation. But fusion, McKinsey did a study about 3 years ago, looking at how much fusion would likely take its place in the supply mix globally. And if we get the overnight cost, it's called down to below 3,000 per kilowatt, it's likely that it'll supply about half, 47%, in the analysis we've seen of the electricity of the globe.
So, jumping over to the company, what does the mission architecture look like for actually going up to the lunar surface, mining, extracting the helium-3, and then bringing it back down to Earth?
Well, we're approaching it in a unique way, which is to say, the team really comes out of space infrastructure, large scale space infrastructure, as well as terrestrial infrastructure. So we have a lot of expertise on the team in terms of multi-billion-dollar projects and how to develop, regulate, get regulatory approvals for, and then finance and deploy these large scale assets along the lines of data centers, solar farms, wind farms, liquid natural gas terminals. So we've assembled an extraordinary team of individuals that have decades of experience in these areas. And we're going to be deploying, these large scale modular elements, much as has been done within, sort of the infrastructure of all terrestrial infrastructure. And in so doing, there's 3 major elements of the mission architecture that involves going to the moon, mining the moon, and then returning with the precious commodities like helium-3 and other commodities. So the basics are you're going to need a large scale deployment system. And luckily there's a huge ecosystem developing in the space industry, which is one of the reasons we're doing it now also. There's this huge step function in reduction of launch costs that's coming both first from partial reusability like the Falcon 9 system that SpaceX has developed, through now to this massive potential for a major step function reduction in a first and second stage reusability of the Starship system with heavy launch capability, 100 tons. New Glen is evolving to a dual reusable first and second stage, as is Stoke, as is Rocket Lab, as is ULA, and so the others are moving towards these architectures. So we're going to have large lift capability, translunar injection down to the lunar surface, hundreds of tons of deployment capacity available to us, luckily being co-financed currently by NASA CLIPS, and also now upcoming with the fission surface power contracts that are going to be deployed. And then there's going to be quick return capacity coming up. A lot of companies are developing return to Earth capability, which is the other half of the equation. So that's, relief. Stoke is developing a return to Earth, as is Intuitive Machines has a pretty interesting program with the Zephyr, as are several others. So that's the full space component. The lunar surface itself, luckily, there's many heavy landers being developed by multiple companies, a very impressive ecosystem there, again, driven by CLIPS primarily. National programs like China, India, Japan, others are looking at ways to land onto the moon, deploy rovers, certain of the technologies that are necessary for mining, helium-3 particularly, or other noble gases, includes gas, volatile gas separation, extraction, sorry. So you can extract the gases from regolith. There's isotopic distillation, which is to say you need then to separate out the gases, separate them via distillation stack using cryogenics. And then you need to compress the gases into these modules that can be then returned to Earth, the valuable ones. And then there's other, obviously, for space-to-space economy, there's going to be emerging other Artemis. There's going to be uses for other things within the regolith itself, which surprisingly is rich. It's the whole regolith strategy, as it's called, has a very rich set of minerals, metals, and gases that are very useful for human and other commercial activities on the lunar surface. And then lastly, the key component, and I'm seeing a lot of this with the great reporting by Astroforge on its deep space network as they're trying to use legacy operators. Is the ground operations. There's a lot of space infrastructure that's going to be necessary, but on the Earth, we're going to be needing to maintain contact, continuous contact with the lunar surface. It's about a 3-second round trip. So many of the mining operations are going to be done autonomously without direct teleoperation control. But that said, there's going to be comms relay satellites. There's going to be a lot of navigation satellites allowing for GPS-like tracking on the lunar surface, as well as nuclear power on the lunar surface. Sorry. So those are all the elements that go into the mission architecture. As you can appreciate, many of them are 2, 3, 5 companies deep in terms of expertise, and a beautiful ecosystem is developing that will supply mining companies like ourselves.
Yeah, absolutely. It's amazing just to see the lunar economy, how much it's grown in just the past 5, 10 years. How do you see the timeline for extraction and return of helium-3? When do we really see that start to become a reality and having it back on Earth?
Well, within the next 5 years, as we look at the market analysis, and again, we're going to be market driven by customer offtake contracts, large companies asking us to help them miss this inflection point where we're gonna run out of terrestrial supplies before we get the lunar supply chain developed. So we've been looking at it. Looks like the massive inflection point on quantum particularly, which is going to be within the next 5 years or so. 2030, 2029, 2031 would be the inflection point where it's going to outstrip terrestrial supply. There's some breeding constructs where we can actually bridge some gap there, but it's capex intensive, capital intensive. But the reality is, in the end, we're going to have to build this end-to-end supply chain and make it robust, diversified, and reliable. And so 2030 looks like the big uptick. And that's good because it aligns also with the big sort of inflection point on launch costs and the maturation of this diverse ecosystem, both within the US here where we're based, as well as around the globe. So we're betting on that time frame for the first major deployments of lunar mining assets on the moon.
And you mentioned Artemis before. Obviously, there's certain locations on the lunar surface that are strategically important and then also have these helium-rich deposits. So what happens if China gets to the helium-3 rich deposits first and claims them? How do we secure economic freedom on the lunar surface?
Superb question. Yes, so it's truly driving us, and Artemis has really just some stub ends in the agreements relative to lunar space resources and other things. So there's really no clearly defined mining regime where, like the International Telecommunications Union in Geneva, where if I have I have a satellite I want to put in an orbital slot, I can go coordinate that orbital slot above my country with my neighbors who have assets, satellite assets in that geostationary slot, 3 degrees, 2 degrees. So that there's definitively a model for coordination of mining claims and keep out zones, safety zones, and within, frankly, the Outer Space Treaty, and then some follow-on work done within domestic efforts, and then what the Committee for Peaceful Uses of Outer Space is doing at United Nations. There's definitively emerging, and by about 2027, we understand with some draft treaties going to be coming out of the United Nations Space Resources Working Group.
Mhm.
But the stark reality is China's making very bold moves to move to set up mining operations, to set up human settlements by 2029, the 80th anniversary of the Chinese Revolution. And Artemis, frankly, and much of that activity is focused on the South Pole, which is where the permanently shadowed regions contain the largest concentrations of water ice, which is necessary for human settlement and other things like propellant manufacturing. But the truth about helium-3 is that it's widely distributed into the dark mares, they're called, or seas, and the ocean of storms. So it's a lot of maritime language. But the Chinese landed, frankly, in the center of the highest concentrations of helium-3 in the ocean of storms in 2020 with Chang'e 5, came back with a 2 kilogram sample, and then recently actually landed on the far side in Aitken's Basin, in an area with some helium-3 concentrations. So it's entirely likely that we'll see China landing, claiming some keep out zones. But remember, the moon is a very large place. Unless they claim the entire ocean of storms or some very radical, sort of abrogation of the Outer Space Treaty, it's likely that these claims would be no larger than roughly 100 kilometers in diameter. And helium-3 is spread pretty broadly in the equatorial regions of optically mature seas, like Sea of Tranquility, Serenity, and the ocean of storms.
Yeah, I'd love to talk PSRs for hours, but that takes us to a good audience question, I think. What would be great to understand ownership, leasehold rights specific to the lunar landscape. Is there a governing body, regulatory body relating to this already?
Well, this is top 5 questions we get as a mining company, as a extraterrestrial mining company. The reality is it's multi-layered. And Antonino Salmeri has written a book. He's advising us now at the United Nations and other locations about multi-level regulatory regime of space mining. So as I mentioned, the Outer Space Treaty in 1967, before we landed on the moon the first time, Soviet Union and America signed, and most nations on Earth agreed that basically no country can claim any celestial body for a national, as a territorial claim. But under it, any entity, any corporate entity under a country's legal system, would be treated as though it were, part of the United States in our case. And then in 2015, after so much lobbying done by the Planetary Resources and Deep Space Industries, a law was passed and signed into law by then President Obama, called the Space Act, which is part of the Commercial Space Launch Competitiveness Act, that authorized U.S. companies under U.S. domestic laws to mine celestial bodies and bring commodities back to Earth for resale under a model that's very similar to the maritime law. So, U.S. fishing fleets can go fish in international waters. It's not prohibited. No other countries can claim international waters, but we can fish there. We can bring back fish for resale here in the U.S. So that is the construct that we are operating under. In the US, there's also regulatory regime relative to operation of multiple space objects. So Department of Transport controls launch up to geostationary orbit through an FCC through ITU. But for anything out into what's called cislunar space, down to the lunar surface, that falls under the remit or aegis of the Department of Space Commerce, Office of Space Commerce under Department of Commerce. And so they are the regulatory body, and we are actually in process of applying for a license for the operation of multiple space objects on the lunar surface. So that is the regime within the US that we're operating. There's three other countries around the globe that have passed domestic space mining laws modeled after ours, 2015, and that would include Japan, Luxembourg, and the United Arab Emirates. And I think it's worth mentioning also that there was a follow-on executive order signed by President Trump during his first term, also reinforcing um, the 2015 Space Act, saying that U.S. companies are firmly allowed under sort of U.S. law to mine celestial bodies.
Yeah, and you mentioned multiple spacecrafts on the lunar surface. Is that something that you'd be building in-house, or would you be partnering with one of these mobility platforms like a lunar outpost, for example, or a few of the other ones that are popping up now to actually provide that mobility on the lunar surface?
Yes, we absolutely will be. Given that mining in any context is highly integrated and complex and technically there's a lot of suppliers for even terrestrial mine companies, purchase dump trucks and mining equipment and commodity supplies from the supply, so the ecosystem, the mining industry. And so in our case, we also are firmly planning to source all of the elements of our mining, both the launch segments, the lunar surface operations, and we're talking about swarm robotics now. We're talking about power plants. We're close to Space Nuclear Power Corp as an example. And yes, we're talking a lunar outpost and intuitive machines and astrobotic and iSpace and others that have certain of the key elements and are leading, in their respective areas about sourcing equipment from them as suppliers. And in 5 years' time, we fully suspect that the Japanese suppliers, Korean suppliers, European suppliers are going to make a breakneck effort to enter this race as well.
Yeah, absolutely. You mentioned the reactors on the lunar surface. This is an audience question. Would love to hear your perspective on the new NASA interim administrator Sean Duffy and his stance on active nuclear reactors on the moon.
Yeah, I read his directive with great interest and a great deal of support. As a designer on the space station, the plan to deorbit it early, it comes as a bittersweet moment, but it's time. It's been flying for 25 years. But more importantly, it's completely aligned. The fission surface power directive that he announced and is now putting actually into motion. In fact, an RFI was just released today. It's due next Thursday for companies that are potentially participating. And remember, we're looking at a total end-to-end mission architecture that's launch, surface operations that includes things like landing pads, and logistics, multimodal, and power systems, and comms and nav that we as a mining company do not want to roll into the mining asset entities themselves. So when this directive came out, that was a perfect opportunity for us to carve out surface power as an element that could be financed distinctly under this NASA program in partnership, and we could prove our model, which is to say structured financing for lunar infrastructure under the aegis of a NASA program, where the NASA contract would be under a power purchase agreement, similar to what I did with the solar plants in my Canadian projects. So we as a company are wholly supportive of this, putting together an industrial consortium to make a bid, but it's hugely accretive to value for mining operations so far that we are deploying standard form 100 kilowatt, Brayton cycle under 15-ton class fission reactors to technically create a lunar surface power utility, which will be for us, rinse and repeat. We deploy them into our mining operations. We'd be, sharing them with other customers. It's an extraordinary development. We're highly supportive.
Yeah, absolutely. The amount of power that'll be on the moon here pretty soon is just going to be staggering. Jumping over to pricing, how do you model pricing for helium-3 when it really hasn't been produced commercially at scale?
This is, again, having developed large scale infrastructure and in case of solar, it's based on kilowatt hours, which is the sort of the metric that you get paid, X cents per kilowatt hour. In the case of helium-3, I've leveraged the same models and same commodity pricing, and there's a lot of dynamic analyses that go into commodity pricing that are hugely applicable here. Because correct, right now the US is producing 10 kilograms. The rest of the globe, Canada, through its CANDU reactor fleet, produces just under 2 kilograms of helium-3 a year. You've got large number of CANDU reactors in India and Argentina, Romania, and a handful of other countries producing diminishingly small amounts. But the big two producers are the U.S. and Russia right now. But pricing is set through rationing. So the Department of Energy isotope program, with whom we have a purchase order at $23,750 per gram
Mhm.
for a small amount, but a symbolic price point, is set by rationing. It's a rationing agreement. So there's a number of applicants every year, research centers, medical folks, quantum and fusion, all send in applications currently through Linde, which is the industrial gas giant that has the license to sell the helium-3. And it's decided, based on the demand and who's going to get which allocation, a price point in the pushing, right now you're right, it's about 20,000 per gram, 20 million per kilogram. That's really established through not a deep liquid commodities market like Chicago Mercantile would demonstrate. So what we've done based on costs, launch costs and what have you, we've modeled overnight, cash costs, it's called in the mining industry, of roughly 12,000 going. And then we did this really hard bend curve just to do some sensitivity runs on the pricing on a commodity basis. And based on certain factors, learning curves, sort of the increasing returns to scale and modularity of the systems and these large scale $2.5 billion mining assets producing around 250 kilograms per year each. And the market demand pulling its vertical for helium-3 because unlike PGM as an example, which is horizontal, the more you supply, the more is demanded because fusion and quantum are just going to be taking off vertically once the supply arrives. So we pushed the model really down just to make sure that it always closes, the economics always close, and they will into the future. So we got it down, in an extreme case to several hundred dollars per gram. So again, it's commodity pricing. There's going to be an options market, futures, calls and puts and everything else, which are really flex, but it definitively closes. It's a very valuable commodity.
Yeah, absolutely. And then we have another audience question. What are the orders of magnitude of humans required to do the work once we start lunar surface operations?
This is great. This is not a jobs heavy program. I mentioned previously that the autonomous robotics will be the core of the mission. We actually won't be deploying humans to the lunar surface as part of our baseline architecture, which is never to say never, but right now we're baselining fully autonomous operations because of that 3-second delay as an example. And frankly, what's happening now with AI and additive manufacturing and autonomous robotics, it's a perfect storm of technical capability to do this now. And so all of our operations will be autonomous. And frankly, the ground ops and the development team that we're putting together here would probably be on the order of 100 to 1,000 employees, ultimately, for full scale development pipeline of projects that we are anticipating, which is to say, fusion could push anywhere towards 357,000 kilograms per year, which is deploying, over $3 trillion worth of capital. So we will be here, hundreds of developers and getting, but then, you get this ecosystem that I was mentioning. Folks turning wrenches and building space hardware and that all being additively manufactured and, suppliers, global supply chain. So, it could be many, many hundreds to thousands to millions of employees globally. But for the peak here, we're at the sort of where the rubber hits the road from a development perspective, it'll be in hundreds to thousands.
I'd also add the autonomous swarms don't really need to worry about the lunar night as much.
Only if you're nuclear. And another portfolio thing, Xeno Power has great radioisotope thermal generators to keep the electronics warm. And long story, but we're talking to Xeno about a lot of different things.
Yeah, we're big fans of Xeno. You
Yeah.
mentioned just kind of company size. How many employees are currently at the company? And then what do you see that projecting to as these missions start becoming closer in timeline?
Well, we just hit a magic number this week. We're at the XMC 12, we're calling them, the sort of the founding core team is coming into view here. So we're just that size. We're spread out a little bit. We're primarily New York and Pasadena, which is where we founded. But folks in Colorado and Seattle and a little further south here and even one actually in Europe. So in Luxembourg City. So we anticipate by the time we're deploying into the 29, 30 range, maybe on 100 employees at that time.
Right. And looking at the helium-3 market or just lunar mining as a whole, do you see this as a winner takes all, or do you think there will be multiple lunar mining companies on the surface of the moon?
We anticipate many
Yeah.
companies entering this vertical. I mean, it's the economics close, honestly. And there's a vertical demand curve on helium-3 particularly as we deploy many more economic assets onto the lunar surface and the space for space economy. I always give a shout out to Anton Brevity now at IBX, then at Prime Movers for coining this phrase. As the space for space economy, lunar economy, cislunar economy emerges, there's going to be no end of space resources that are going to be required for manufacturing of everything from habitats to fuel to oxygen to breathe, everything. And so, we fully anticipate pretty, pretty strong uptick in demand over time.
Yeah. And then could you walk us through some of your offtake agreements? Are they binding, conditional, or exploratory?
We've got all three. And so I did mention the purchase order from the isotope program at Oak Ridge National Labs. Again, they're in charge of isotope program. There's several other much larger scale offtake contracts and discussions with the U.S. government, insofar that the U.S. government will play a role in establishment of the Strategic Helium-3 Reserve, as an example, modeled after the Strategic Petroleum Reserve and previous Strategic Helium Reserve, which was necessary for airships 100 years ago.
Mm-hmm.
And so those are in discussions. We are also deeply in discussions with several industrial gas companies that do have extensive Rolodexes within, sort of the research university, other markets, but also primarily quantum, both on dilution refrigeration and into the quantum data center folks like IBM, Google, Microsoft, Intel, D-Wave, others. And then into fusion, obviously, while deuterium, tritium is baselined right now, it is a radioactive fuel cycle, insofar that it irradiates the magnetic containment vessels for the various architectures like Stellarator and Tokamak. But the real bleeding edge there, and really what's getting deployed commercially right now, are these field reverse configurations like Helion, which has deuterium and helium-3 in its fuel cycle. And so, we're talking to the actual fusion reactor companies. Tri-Alpha Energy is another one down in Orange County, California. But they're going to be deploying these massive fleets into the investor-owned utilities. Like if you look at the top reactor fleet operators right now, you've got like Con Ed, you've got Constellation, Exelon, NextEra, a bunch of others that operate large numbers of nuclear reactors. So we're in discussions with all of those various verticals and industrial majors.
Yeah. Then jumping back to, I think, some of the technology on the lunar surface that your team's working on, could you explain the technology behind the extractor separator compressor unit and how it operates on the lunar surface?
Yeah, that's the core of the tech is in development, and we know that there's a number of different players there. I mean, the Colorado School of Mines in particular is a really strong player here, insofar that Chris Dreyer and Angel Madrid there. The students have been doing a lot of work here. University of Wisconsin, another strong player here, looking at a lot of these early stage technology development challenges, frankly. For the volatile gas extractor, there's a number of different major players looking at that. Interlin is a leader in that from a technology development perspective. But we've also got, Honeybee Robotics has developed a volatile gas extractor for some of the missions out to the asteroid belt, as has Airbus Defense and some others. So the gas extractor component is again relatively well understood tech. It just needs to be ruggedized and hardened for space operations at scale. These are not just one-off samples that are being taken for a scientific mission, but you can be operating this thing, for 10-year terms, 1,000+ tons per hour kind of volumes we're talking. So that's the extractor component. That's going to be mounted onto mobility solution that, by the way, vibration actually releases helium-3 from the lunar regolith. So there's all sorts of different constructs about whether you use a bucket wheel extractor, a little bit like you would here on Earth, but then you might technically lose some of the helium-3 as it's vibrated. There's some hooding architectures that have been proposed under various schools, what have you. But the reality is you need to simply move a lot of regolith through to get to these relatively small concentrations of helium-3 and other noble gases like xenon, krypton, argon, etc. And then into the separator, which is this isotopic distillation to separate out the gases. There's a couple of different companies that are doing cryogenics, and particularly, we've been working with Lindy's Cryotechnik group in Germany, as well as some other folks like Absolute System in France, formerly Air Liquide folks. And then right down, so you can separate all the gases down to about 4 Kelvin, but once you get to helium-3 and 4 together, it is the most challenging separation that you've got, gas separation ones. So you actually need to use a dilution refrigerator, which is what it does. It separates the two, and which is what drives the refrigerant down below 10 millikelvin. But you need to deploy this on the lunar surface as a dilution refrigerator solution. So we are talking to dilution refrigerator manufacturers, and there's several globally as well. And that's been an updrafted business as well. And then into the compression, that's a relatively well understood technology, like Burkhardt compressors out of Switzerland and others, down in Woodland, Texas. Chart Industries has some of these technologies. So you're looking at ways just simply to compress the gas down to about 350 bar, which is about 5 kpsi, which is, if you've ever heard of a Toyota Mirai or Honda hydrogen cars, they have 350 bar to 700 bar tanks, which are about 7 kilograms each. But we're going to be doing it into a 2-meter spherical tank on the order of about 300 kilograms of helium-3.
Yeah, awesome. And then we have another audience question. Can you speak to how XMC is part of or not part of a lineage of space mining ventures? What have you learned from past efforts, and how are you folding those lessons in?
First and foremost, mad respect to the teams that came before us. I sat down with Dan Faber and Chris Lewicki and Joe Landon and several others. That was my first mission, was to go have lunch with the founders of Planetary, and recently in discussions with James Orsolak, one of the other early guys at Planetary, is really to find out what they feel went wrong. Obviously I've been referring to this is the moment, sort of alignment, because there's political pull, there's market pull, there's technical maturity, there's launch cost reduction that's coming from SpaceX, which didn't exist 10 years ago. And so, now is the moment, is your reality, which answered most of my questions in terms of like all of those things, costs and closing the business case. And in Planetary in particular, it did yeoman's job of developing asteroid hunting satellite, et cetera, and started thinking about optics and prospecting for claims, and then doing all the legal heavy lifting relative to getting the Space Act executed, as did Deep Space Industries. So tremendous amount of respect. In simple terms, they were simply too early, and so 10 years ago was just a squinch too early, but right now, given everything else that it's aligning, now is the time.
Yeah, couldn't agree more. What is the current status of the project financing, and then what milestones will the next round target?
Well, we're migrating. We're closing our seed round now. We're actually opening a Series A of 50 million, which will be more classically venture minded as opposed to the early stage family offices and seed folks.
Mm.
But on the project financing itself, that requires a creditable off-taker. So that's, again, when I mentioned all of the IOUs and the data center folks, those are creditable off-takers. And so to the extent that we negotiate an offtake contract from one of the major players with either the US government or and frankly Fortune 500 balance sheets that can basically allow us to close the rest of the financing around that. That we anticipate to be the major milestone. The use of funds for the seed is actually to negotiate at least letters of intent in multiple industries to allow us to close the Series A. So that's the major milestone and value creation elements of what we're going to be focused upon with our currently closing seed. So into the next, we're the major into the Series B, et cetera. We're going to be really just more pulling, developing, pushing out a lot of non-recurring engineering in partnership with some of the lead developer technology companies that we see where we may need to adapt or specialize equipment or something elements like that. But overall, we see, out past Series B to be really will be self-funded off of revenue coming off of the mining assets.
Okay. And you touched on it before, but just the thought of inflection points, both in the terrestrial market, but also launch and technological maturity. What does Starship coming online mean for the company?
Well, I'll be blunt. I made two models. I made a Falcon Heavy based model and I made a Starship based model. And it's an order of magnitude in economics. I mean, we can just close at a much higher price point per gram of helium-3 for the Falcon Heavy deployment. That was intended really for, okay, between now and 2029, can we make a mission work on a relatively smaller scale? And again, it was 100 kilograms a year as opposed to 1,000. And so, the difference is it just kicks the door wide open economically. The economics close, the cost per gram, our cost per gram drops down into the hundreds to tens of thousands, 10,000 range. And so it just that matches that inflection point on the demand side, on the pull side, with both quantum now. Like quantum is actually inflecting now, which is not a well-known story. So we got a lot of dilution refrigerator manufacturers looking around for where are we going to source terrestrial helium-3 now that we can't get enough. And then the fusion, listen, Helion just broke ground on its 50 megawatt reactor for Microsoft coming online in 28, maybe. And then 2030, they get a 500 megawatt reactor coming online for Nucor Steel, one of its major investors. So helium-3 based fusion reactors are going to be deployed commercially here in the next 3 to 5 years. And again, the 500 megawatt will outstrip the global supply in its first year of operations.
And I know we've been focused pretty heavily on helium-3. What are the other isotopes or different materials that you'll be mining for on the lunar surface?
Well, we've again our industrial gas partners, several of the various distributors globally have expressed interest. There's a lot of other noble gases. I mentioned argon, xenon, krypton, that are way down the value curve in terms of but if we're bringing it back as a bundle, there's likely that we'll bring back some of those gases for terrestrial markets. But frankly, the big next sort of valuable commodity that's in the regolith, no matter where you are, yes, it's high. Water is highly concentrated in the PSRs, yes, but it does actually also exist in the regolith distributed into the equatorial regions where we'll be concentrating the helium-3 mining on. So water, and we've been in discussions with some of the folks that are planning to do propellant manufacturing both on the moon and creating gas stations in space, and then that would be sort of Orbit Fab and Starpath and a few others that are primarily LOX, but you've got hydrogen as well. And our Stoke partners they have a Hydrolox propellant based architecture. So honestly, you could produce propellant for Hydrolox based on what we could be extracting from the regolith and will be. There is, interestingly, where the helium-3 is highly concentrated based on this magma movement within the lunar crust. You actually also have high concentrations of platinum group metals and rare earth elements. I use earth loosely here, rare lunar elements, I guess we might call it. But technically, they're extraordinarily valuable. And as we, again, electrify our economies here on Earth, things like antimony, yttrium, and other rare earths are going to become extraordinarily valuable. And I know that U.S. is really pushing, sort of a critical minerals, metals capability domestically. And here's an extension of the U.S. economy to the lunar surface where these elements exist in abundance.
Yeah, absolutely. The rare earth or rare moon minerals is a huge tailwind. We have another question from the audience. Are there any meaningful technical hurdles required to achieve commercial operations?
Yeah, I think I also top five question. Leaving aside, we have confidence. The launch market, mature, diverse, strong leaders really emerging like the top three plus one, so you're really getting into this, and even government, pushing hard into this like Europe and China and others. So we're confident in the launch and return elements. Even the return to Earth folks with inflatable, sort of heat shields, and some of the like Nick's out of the exploration company, capsules coming back in Varda is a great example. Folks that are developing, return to Earth as the last leg of the lunar economy, sorry, the orbital economy. The sort of in the technical stack, and we've identified this particularly early. I'd give the most complex technical challenge award to isotopic distillation. Cryogenics, is tricky business here on planet Earth, meaning it's done at scale. Distillation stacks happen. We can separate gases and, air sep plants, et cetera, that are deployed in steel mills. And recently, at SpaceX is installing its own air separation plant to create its own liquid oxygen. But on the lunar surface, you've got to ruggedize and protect and make durable these technologies on a lunar surface, an operating environment that has lower gravity, that has micrometeorites and larger meteorites raining down upon it. 2 week lunar nights, thermal swings of several hundred degrees Celsius, and this at the end, this lunar regolith that has been described as razor-bladed talcum powder with an electrostatic charge. So it's going to get into all the working mechanical elements that aren't protected properly. So I would say that is the highest technical challenge, because also remember, I may not have made this extraordinarily clear, but the economics of returning the gas to Earth dictates that we have to separate out the helium-4 and helium-3, because the ratio is such that we'd be bringing back over 99.999% helium-4, which would be great for balloon animals, but it doesn't have anywhere near the economic value of helium-3. So we have to figure out isotopic distillation right down to that last separation.
Yeah, that's a great question. And then what does success look like both for you, the lunar economy, by 2030 for investors and humanity?
Well, this is a question we obviously ask ourselves and explain to investors quite regularly. But mining, in our opinion, is an apex economic activity in the emerging cislunar economy. Right now, the big export, this $400 billion space economy, is primarily data. We've got telecommunication satellites, we've got broadcast satellites for radio and television, we've got two-way comms, we've got Earth observation, science, et cetera, all really focusing upon data, exporting data from space, which is huge. But as we get into the molecular market, what is worth bringing back? We believe, military is driving a lot of innovation, a lot of asset deployment into the cislunar architecture. Could drive, like it did on Earth, could drive out navigation, sort of a lunar GPS. It could drive out comms. There's going to be comms all around the moon and lunar observing capabilities, much like we have here on Earth. And so military and then civil, like NASA is also driving this out. But the reality is you need commercial activities. And the number one, the only commercial activity, and I looked at all of them, given my years of experience and the team, helium-3 mining for space resources is the apex. And so success in 5 years' time would look like there's a thriving, diverse commercial industrial ecosystem in the cislunar environment that is partnered with civil and with military, but is really driving it as we do, as that drives the US economy and other economies on Earth.
Absolutely. I think we have time for the last two audience questions. What are the cybersecurity precautions for mostly autonomous operations?
Well, it's a non-trivial issue, and we've looked at it from the beginning because what my protostar experience was such that our second satellite actually was jammed by a Chinese military asset in geostationary orbit. And so we actually, as a commercial entity, had one of our assets commercially attacked and compromised. And so cybersecurity and actual passive defensive mechanisms are designed baked into our overall mission architecture from the beginning. And so what we've done is we partnered with several leading providers of cyber secure comms, particularly. So we'll be building out a very transparent but secure data architecture that can't be tampered with. And then on top of that, we're adopting many of the space warfighter methodologies for passive defense that was written up by the Rio Space Force recently in a very good white paper. But to take things like disaggregation and diversification and sort of active counter jamming and shielding for kinetic attack and sort of all of that methodology is going to be baked into our lunar mining operations because we're going to be expecting the worst, but making sure that the risks are identified and mitigated to the maximum extent possible. So cybersecurity was number one concern.
Yeah, and I know the DoD's prioritized that as well through a couple of different initiatives.
Correct.
And then last question, on the topic of isotopic distillation process, can you explain more what is preventing you from doing the distillation back on Earth?
Yeah, just it's sort of the corollary to my point before. We can bring back 300 kilograms of gas compressed to 350 bar. There's other methodologies. We can go up to 700 bars, so, higher pressures, et cetera. But we baseline 350 bar or 5 kpsi. 300 kilograms of helium-3 is a sorry, it's it's $1 billion plus payload, right? If we kept the gases undifferentiated, unseparated, we'd be looking at, hundreds of dollars of helium-4 in that tank and diminishingly small amounts of helium-3. And so it's incumbent upon us, we absolutely must separate the two gases on the lunar surface, leaving aside all the other gases that'll be coming out of the distillation stack at much lower, at higher temperatures, sorry. So it's an imperative.
Yeah, absolutely. Well, Glenn, I think we're about at time. Thank you so much. I know we could go on for hours on this, but thank you for your time. If there's a best place for people in the audience to reach you, website, let us know and happy to direct them there.
Yeah, absolutely. Reach me via email, Glen with one N .Martin at xmcspace.com. I'm on LinkedIn, I'm on X. Reach out anytime. Glad to engage with anyone with any technical or other questions. And Emerson and the rest of the team at Valerian, I cannot thank you all enough. It's been an honor and a privilege.
Absolutely. Yeah. Thank you so much.
Thank you, everyone.
And we'll have a recording of this available tomorrow. So in case anyone missed it, we can share it there. Thank you.
Thank you, Emerson.
Bye.